Okay, now that we know how to name points and planes, etc., now we're going to learn what happens when they intersect. So, what does intersection mean in everyday life? Go ahead and write something down. I'm pressing pause. All right, I came up with two words. It's where things cross and it's where things meet up. So think of an intersection, four-way intersection. It's where two roads meet up with traffic lights. Okay? So where does AX intersect CM? This looks familiar because we did it in the last video. So we have AX and then we have CM. Notice they met up right here in the middle at point N. Okay? Does RN intersect X? So remember, if I've got some dotted lines right here, I've got a pencil going through the paper, so I know R is not on the plane, it's in the air. So RN is going to intersect AX right here at point N. Okay? If you need a visual example, I can get a sheet of paper and a pencil. Do you see any other intersections? Do you? Hopefully you said yes. Okay, so we talked about these two lines. And then we talked about RN and AX, but did we talk about RN and CM? Okay, so CM and RN are actually going to intersect at N as well. Okay, so since I had three lines, I had three intersections. What do you notice when two lines intersect? So what do you notice about this and this? Hopefully you notice it's one letter. So two lines intersect at a point. And that will always be true, unless it's a line on top of a line. So if you've got two lines crossing, you will get 1 point. All right, let's look at a cube again. So based on the cube, name the intersection of FG and FB. Name the intersection of EH and DH. And then what can you conclude about the intersection of two lines? So try those on your own and press pause. You notice that FG would be here and FB is right here, and so they intersect at point F. Same thing for EH and DH, they intersect at point H. Now, what can you conclude about the two intersections of lines? I said we already know that two lines intersect at a point, but did you just learn that the letters are going to repeat in the line segment, therefore you don't even need a picture. So for example, I know F appeared twice, therefore the intersection is F. Notice that H appears twice, the intersection is H. So you don't even need a picture if you are intersecting two line segments or lines. Fun fact. How cool. Alright, so based on the postulate or theorem or rule, two lines are going to intersect at exactly 1 point. Make a prediction about two planes intersecting and do not say a crash. So jot something down. When two planes intersect, what happens? Alright, so I have a picture here for us to help us out. So notice I have one plane in gray going up and down, and I have a plane in blue going left to right. Here is their intersection right here. So what happens? Hopefully, you said a line is formed. Okay, line segment, etc. So, two lines intersect at a point. Two planes intersect at a line or a line segment. Okay, so that's always true. Now, if you need any help visualizing that, I can totally take a box out and show you. Otherwise, we're ready to move on. So we're going to talk about intersections of planes from now on. So based on the cube, name the intersection of plane H, G, and F and plane A, B, and F. So I'm a visual person. I like to color things. H, G, and F. H, G, and F is the top of the box. Okay, I'm going to go ahead and shade it in red. That's the top. ABF. A, B, and F. A, B, and F is the front of the box. So, if you can see it, you can know the answer would be E and F, or F and E. Now, if you can't see it, you can say, well, what is the top front piece? The top front piece would be EF or FE. And then if you want a way that will always work, the whole repeating of the letters thing, you can name the fourth point. For example, like I can see F is repeating, but I don't have any other repeating letters, so I know F is a part of it. So the fourth point in H, G, and F would be E. So it's H, G, F, E. The fourth point in ABF is E. So it's ABFE. And then you can see that you have repeating letters. Okay, so you got a couple options. You can shade them and see their intersection. You can say the location, so top, front, back, left, etc. Name it from that. Or you can write out the four letters and see what repeats. Okay, so based on the cube, I want you to name the intersection of E, H, and D, and H, G, and C, and see if any of those three ways can help you check your answer. And then what do you notice about the intersections of two planes? So press pause and try them on your own. Is HD or DH? Okay. So I'm going to go through an explanation right now. If you got it, please skip over my explanation. But E, H, and D was the left side, and so the fourth letter was A, and it's also on the left side. And then H, G, and C is that back part of the box, and so the fourth letter was letter D. So I can see, I'm a visual person, I know it's HD, or if I wrote out all four letters, I know H and D are repeating, so that's my answer. Or I could have said, hey, what's the left back part? The left back part would be HD, okay? And then do you notice about the intersections of two lines? A plane is formed, so please don't give me one letter when it says what's the intersection of two planes. Always give me two, okay? All right, let's move on to parallel and skew lines. So these were our vocabulary words, so go ahead and tell me what's the difference between parallel and skew lines. So press pause. You remembered that parallel lines and skew lines are never going to intersect. However, parallel lines are in the same plane, and then skew lines are in different planes. So that's the only difference. Parallel's in the same, skew is in different. So here's a fun picture of a cool 3D shape. Let's talk about some parallel lines. So I've got EZ and then AV are going to be parallel. They're in the same plane and they're going, they're going to never touch. Skew lines, so EZ and then give me something that's not parallel. So don't pick WB, you could pick WX. So they're not in the same plane, they're going totally different directions, and they're never going to intersect. Fun fact, EZ and CX are actually parallel, right? They're going the same direction, they're in different, or they're not in the same plane. But here's the confusing part. You could kind of connect a plane right there. So it looks like I kind of cut something diagonal, okay? So CX and EZ don't look like they're in the same plane. However, you can draw a plane to go through any two parallel lines. So a diagonal plane can go through and hit 2 points, okay? So if you need an explanation, I can totally give you another one. All right, let's look at cubes. So based on the cube, tell me all segments that are parallel to AB, and then tell me all segments that are parallel to CG. So try those on your own. Press pause and we'll go over it. So when I named all the segments, I had CD, HG, and EF. Again, you can have them in any order. So here is AB. And so we know DC and we know EF because they're in the same plane. Now you probably are asking yourself, well, HG is totally not in the same plane as AB. Now, again, like I tried to describe in the other one, I could draw a box or a plane that would connect those two. So it looks like I have like a cardboard, like a whiteboard laying in a box. So a plane can be diagonal and still be parallel, okay? Same thing down here, we've got CG. So I have CG, I know BF is in the same plane, and I know DH is in the same plane. However, AE is also parallel to CG. They don't look like they're in the same plane right now, but I could draw a diagonal plane. So I could kind of cut that box diagonally and I could still be touching AE and CG. Okay? All right, moving on to perpendicular. Remember, perpendicular is when you have 90-degree angles. The symbol for perpendicular is an upside down T. Okay, so that symbol means perpendicular. So when I have AB, I basically want to know what lines are going to touch that and make a 90-degree angle. And luckily in a box, you've got all 90-degree angles. So right here, AE, that would be perpendicular to AB. And that's how we write it. I also have BF. That'd be perpendicular. So BF would be perpendicular to AB. And the last one, AD, that'd also be perpendicular. Okay, so those would be the three line segments that would be perpendicular. So why don't you go ahead and tell me the line segments that would be perpendicular to CG. Press pause, try it on your own. Shortcut, so I didn't have to write all this out. But I know DC would be perpendicular because it runs into it. I've got BC would be perpendicular, and then I have FG would be perpendicular. So it's basically all roads that lead to that line segment. There was also HG, just found one. So are we missing one on AB? Yep, we missed CB. Whoops. So there are four, because there are four sides to a box. So my bad. So you should have four line segments that are perpendicular. Moving on to skew. All right, based on the segments, tell me what is skew to EF and then skew to DH. So make sure it's not in the same plane and it's not parallel. So press pause and try those on your own. Skew lines are kind of hard to find, but here is EF. And so it can't touch it at all, so it can't be this line, it can't be this line, it can't be this line, it can't be this line. Then it cannot be this line because it's parallel, so you can't click or you can't write any of the parallel lines. And so you have to go in a different plane, so go above it, and then going the opposite way. So you've got BC in any order, you have AD in any order. So these are skew, and then you also have the backs. So they're going up and down, whereas this one's going left to right. So they're never going to intersect, and they're in opposite planes. Okay, so you should have four answers in any order you want. Then you've got DH. So I'm going to kind of erase this and help you out. So DH would be here. So we're trying to get some lines going left to right in opposite planes, which would be this one and this one. So they're in the front and DH is in the back, so they're never going to intersect. And then you also have GF. I'm going to erase that for you. So then these lines over here, they're in different planes and they're never going to touch DH. Okay, so that is definitely a C. Okay, so let me know if you have any questions on skew lines. Otherwise, we got one more slide, so hang with me. Parallel planes. So they're like parallel lines, except they're planes. So name me two sets of parallel planes. So I can say the top and the bottom. Those are going to be parallel. They're never going to touch. So give me one way to name the top. I could say ABC. Give me one way to name the bottom. We could say plane E, F, G. Again, there are so many different ways to name the plane, so you could have named it a different way and gotten the correct answer. And then gave me two sets of parallel planes in this room. So think about my classroom and go ahead and jot down two examples of parallel planes. So you could have said the ceiling and the floor. You could have said the front of the room, the back of the room, the window wall, and then the opposite wall. Okay, so that's examples of parallel planes in my classroom. And to end, we have a nice punny joke. So you got two kids in elementary school. They're saying plain geometry is hard enough. What will fancy geometry be like? Ha 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 ha. Like plain, like boring, fancy. Haha, get it? Okay. Thanks for watching. Now you can practice.